Hi everyone, my name is Jackie and I'm really excited to do this activity with you guys today. So first, to start off, I'm just going to share my screen with you guys to give you guys a brief introduction into, as Kathleen mentioned, this technique. So basically, what is chromatography? It's a big scary word, but it's just a separation technique. As Kathleen mentioned, we use it a lot in the sciences, but there's a lot of different varieties of this technique. But whatever variety it is, there's always three main components of this technique. So you always are going to have an analyte, which in our case is going to be marker ink. And that is, you can think of as your mixture or what you want to be analyzing or separating. And then you're always going to have a stationary phase. And in our case, we're going to use this filter paper and a mobile phase. And we're going to be using water. So as the names imply, the stationary phase is there to stay put, and your mobile phase is what's going to be moving and creating the separation. So this is just a quick animation here so you guys can visually see this. So we're going to have our stationary phase here in green is just going to be our filter paper. We're going to put a ink blot or drawings, and then we're going to have water come in, and it's going to move up the filter paper due to capillary action and cause this separation to occur. As you can see here, you're going to get this gradient effect because the pigments are going to separate and they're going to have traveled a different distance. And what causes these pigments or molecules to travel different distances is because they are going to interact differently with the water. So if they like the water a little bit more, they're going to want to move up a little bit further with the water as it comes along. And if they like the stationary phase a little bit more, they're going to want to stay where they are in the stationary phase. So that causes this gradient effect and the separation of the different pigments or components in any sort of mixture that you're trying to separate and analyze. So that is just how chromatography works. And this is just some examples of where chromatography is used. In the bottom left here, you can see it is used a lot in science, in the sciences when we are making different compounds and have a lot of different mixtures. But in the top left here, you can see that this is dirty water. So it's used a lot in the environmental sciences or in field work when you're collecting samples and you want to analyze the mixtures or you want to find what pollutants there might be in the water. So it's also used in forensics, as an example here in the top right. And when you go into a crime scene and you just collect samples, you want to figure out what is in those samples in order to solve the crime. And in the bottom right, we have a medical scenario. So it's also used a lot in biology and in the medical field because our bodies have fluids and mixtures. We want to figure out what is in them in order to figure out what we want to do with like our blood samples or other types of samples that we get. And then finally, I also want to call attention to this phenomena that we don't appreciate as much, but it's something that's very important to us in our everyday, and it's just how our eyes perceive color. So as I mentioned, we're going to be working with pigments here. So something that I just want us to recall is that when we see red, it's actually because light is hitting the object and reflecting red, and all the other colors are getting absorbed. So that's just something that I hope you guys can keep in mind. So then to start off with the activity, you just want to get coffee filter paper, and I like to fold it up into a little cone just to start off so that it's nice this is how it is going to be going into the cup also, but it's also good to give us an idea kind of where the center is, because this is going to be our flour and we want it to have a center in the middle. Also, before I go any further, I do want to have this for you guys to see. So if you guys want to tag us, here are our social media accounts and also hashtags, because you guys can share your recreations with us so that we can see what you guys did, and also so that you can inspire other people. But basically, you want to get filter paper, fold it up, find a center, and the next thing you want to do is grab your markers. The only thing I want you to note is that it's best to use water-based markers. They don't have to be washable, but as long as they're water-based. For example, Sharpies are actually alcohol-based. And the reason for that is, if you remember, our mobile phase is going to be water, so we want to be working with markers that are water-soluble and are actually going to like water. And if they like it more, they're going to move up more, as I mentioned earlier. And so you can choose whatever color you want. You can get creative, but I'm actually going to choose black for that reason that I mentioned earlier, is that black is a little bit interesting. Some people consider it more of a shade rather than a color because it actually absorbs all colors and doesn't reflect any. So when we think about what is in this black marker, what kind of pigments are in it that cause it to absorb all the colors, we can start to wonder what we might see here. So I encourage you all to form a hypothesis on your own of what you might expect to see when we use chromatography to separate our black marker. So the other important thing before we start off is that the reason that I folded this paper to know where the center is because when we dip this in the water, we don't want the ink to have immediate contact with the ink. So you want to leave a little bit of the edge here without any ink on it. And then you guys can get creative with your designs. I like to have it look a little bit more flower-like by just having a petal-like design, kind of like this, that goes around the flower. I've also tried dots and hearts, but you can really use your creativity here and do a lot of, if you do mixtures of colors too, that ends up looking nice. They'll start to overlap sometimes too. So you get these nice combinations, and I'll show some more examples later. So that's just my design. I'm just, again, using all black just so that we can see what happens to our black ink when we subject it to chromatography. And I also left a little bit of the edge white. You can go draw further out, but it might just take a little bit longer for the water to go all the way to the edge. And also we are going to be cutting this at the end, so it doesn't matter too much, but then you want to fold it back up into the cone shape that we had in the beginning. And then here you want to grab your water. I actually experimented a little bit with the level of water, and you can have less water. It will just take longer to fully go up the paper to the edge. If you have a little bit more, it goes faster, but you have greater chance of getting kind of more smearing here in the bottom and less of slower gradient. So there's no kind of right level, but the one thing that is important is that when you first dip the paper in here, you kind of do it slowly, as I mentioned before, so that you don't have immediate contact with the water, but it slowly rises up. And I'll see if I can get a closer shot of this. As you can see, it's already slowly starting to rise up, and then I can slowly drop it down a little bit more. And there it is going. Also, if you have any questions right now or at any time, you can feel free to put them in the chat. It can be related to this or to chromatography in general if you're interested in learning a little bit more about where else it's used and all the different types that we have. Once this is in the water, it's best to not move the water too much because it can disrupt the water rising up, but I'm just going to put it a little bit off to the side. We'll still be able to see how it's moving up, but in the meantime, I do want to show some examples that I have so that we can see. So this is actually red and purple, but we can see that the red actually gets separated into some pink. So there's some pink pigment in our red marker, which is probably why it's not as a dark of a red. And this is actually might give you a little bit of hint about the black, but this is gray and blue. So I don't know if you can see too well, but the gray is actually looking a little pink, which is pretty, but it's not what I expected. And this one was just with a little bit less ink. And also I can, with these examples, I can show you how we're going to create them into these flowers. So you want to start off by, once it's fully dry, once we get them out of the water, it takes probably about 10 minutes to dry or so, not too long. So you can fold it back up, and I just do this so that it's easier to cut the edges, but I do want to kind of go around here and cut petals so that it resembles more of a flower. It doesn't have to be completely perfect. I also forgot to mention, but there is a butterfly option. So if you want to do a butterfly, you don't have to cut these petals out. The final product just ends up looking a little like this. And so you can see here, I kind of just cut a circle instead of the petals. But those are the two options. So I'm going to make this one into a flower. And when you open it up, you should have something like this. And the next thing you want to do is kind of carefully pinch it in the middle so that it's kind of opened up a little bit, but you still have something to grab on. And then you want to get a little bit of tape. This just makes it easier so that it's held in place when we want to create our stem. So once it's pinched, you just wrap the tape around. And then you have that. And then you can grab your pipe cleaner. I like to use green so that it can resemble our stem a little bit. And then you just want to take the pipe cleaner and wrap it around a few times around the taped part of the flower so that it stays in place. Like that. And then you can go in and open up the flower a little bit more. And there we have our flower. And you can make a lot more and have a whole bouquet of very colorful flowers and put this in a vase. Mother's Day is coming up, so this is, I think, something that'd be very cute to give to all the mothers on Mother's Day. And also, I'm going to show you quickly how to do butterflies because it's very similar. So you just want to take this, and I like to cut the edge just a little bit if you do have some that didn't quite finish. Oh, sorry. Before we go there, this is actually a little bit ready. So you want to just carefully pull it out of the water. I don't want it. So if you let the water fully run, the ink is all going to go to the edge. That's if you leave it running forever. So you're not really going to have any ink in the bottom. And you can slowly open it up just so that you guys can see. This is what our black ink looks like. So I was a little bit surprised to find that I don't know if you can see very well, but it's shades of pink, purple, and green mostly. That's mostly what we find in our black ink. And then I just want to carefully lay it down flat so that it can dry. But you can see we get a very pretty flower and gradient design from our marker. And if we go back here to our butterfly, I just want to trim the edge a little bit to get rid of some of the parts that didn't get fully resolved. Once you get rid of that, you can just open it back up, and then you want to just pinch it in the middle to create kind of like a bow tie. And this you don't have to necessarily tape. You can tape it here in the middle, but what you can also do is just use the pipe cleaner to hold it together, and that seems to work pretty well. So I like to first just fold it so that they're in half, and I get two antennas that are approximately the same size, but you can always just cut these afterwards anyway. And one's a smaller butterfly, so it's a little bit, again, you just want to wrap it around a few times. And then I like to wrap the antennas around together so that they stay put. And then you can trim them if you think they're a little too long, or keep them as is. Maybe fold them a little bit, and you get a nice little butterfly like that. So yeah, I think that is most of the activity. Please share your recreations with us using the hashtags and also by tagging us, because we would love to see all of your different designs. And if you have any questions, again, this is, if any of you were right in your hypothesis about what colors you expected to be separated in the black marker, also let us know. Cool. So I hope to see some flowers and butterflies.
Jackie, I have a question.
Yes.
What do you do in grad school?
That is a good question that I ask myself a lot, right? So I'm a first year. I'm starting out. I'm taking classes right now in TA. Mostly what I am doing, what you focus on your first year is kind of just like taking your classes and also TAing. I TA for Gen Chem labs, which is really fun because they're all first years also, and they have a lot of questions that really and they're really excited and everything's new to them. And then for research, I am interested in polymers. I got interested in polymers because I wanted to learn more about how we can make recycling more efficient. So I'm still starting out and seeing where I want to go move forward with that. Yeah. There's a question, what other paper can you use to make the flowers? So I think that the reason filter paper works is because it's pretty thin. It doesn't work if you use something, for example, like construction paper. I haven't tried, actually, that is a good question. I haven't tried anything other than filter paper. I actually have different coffee filters that are made out of recycled paper, and for some reason it doesn't work as well. And my only guess is that I just think, so the reason the separation occurs, as I mentioned, is you have to have some sort of attraction between the molecules that you're trying to separate and the mobile phase, and also some attraction with the stationary phase. And so I'm guessing that the marker tends to like this recycled paper more. I think it's a little bit thicker too. So it tends to stay put in the stationary phase and doesn't move up with the water as much. So you don't really get much separation. Yes, Virginia, that's a good point. I think a paper towel would also work. I think that paper towels are also, depending again on the paper towel, they're a little bit more fragile sometimes. I think those might rip a little bit, but I think that might also depend maybe if you have like 2-ply or what kind of paper towel you have. And what else can you separate? The possibilities are really endless, actually. That's something really interesting about chromatography is you can separate even different phases. If you have things in like a gas phase, you can separate gas mixtures. If you have them in liquids or solids, you can do all sorts of things. Possibilities are really endless. You just have to, based on what you're trying to separate, change the properties of the mobile and stationary phases. So I think if you were to switch to a different liquid like ethanol, maybe you would have to try alcohol-based markers or Sharpies. So that way they're compatible with the ethanol. But my guess is that you would probably get similar results if you use the filter paper and ethanol instead. Yeah, I would have to try that out. Now I'm interested to see what kinds of, so the patterns are most likely always going to be kind of similar. It's the separation isn't in like discrete bands, it's more of like a gradient, and that's because we don't really know actually what's in these markers, but the pigments are just all pretty similar, so it's really hard to get very defined separation. It's more of like a gradient that you get. And why did the black come out as green, pink, and purple? So if you recall, black is kind of the absorption of all the colors. So the best way to kind of get that is to have all of the pigments present. It's not, we don't have all the pigments, so we don't have like a rainbow, but what we find is that if we have a mixture of these colors like green, pink, and purple, then you're absorbing all of the other colors. So when you combine them, you're getting the whole spectrum. So you're absorbing all of the colors at the same time, and your eyes aren't seeing black. These are all really great questions. If you applied more black on one section, would there be more varieties of colors on that section? Or would the color there just become darker? So we did apply black just on certain sections. So do you mean if you only put like one dot? Because I think the variety of color that you get doesn't depend on how many dots of black I put. It's always going to be separated into the same varieties of colors. I actually did the black trial a couple times, and each time they were different designs, and sometimes this one was left to run in the water for a little bit longer. So you can see that most of it ended up in the edges because I just let it go for a little long. But you still see always just mostly pink, purple, and this kind of greenish color that come from the same markers. I don't know if that answers your question about putting more or less black. I don't think it changes too much the variety. So that is also a good question about using different varieties. I tried with only Crayola because they have this monopoly on markers, I think. But I did try the washable and then the regular ones, and they both work the same. Haven't found other ones, but I think most, if they're water-based, they should behave pretty much the same. And even the blacks, actually, both different kinds, the washable and the non-washable, the blacks were still made up of those same colors. But unless Crayola doesn't, yeah, I guess that's true. That's an interesting question. There's probably different combinations of colors that you can use to get a black overall ink. So that's a good point. These are all really great questions. Now I want to do all different kinds of chromatography with different markers and different mobile phases. Like I said, there's a lot of possibilities, and hopefully this inspires you to see how you can use chromatography in your everyday life and then in your more specialized job or profession that you do in the future.
So if nobody has any other questions for Jackie, yeah, please post all your pictures of your flowers and your butterflies. We'd love to see all the color patterns you come up with. If you found black markers that aren't Crayola markers, we'd love to see if those have different colors, if you somehow broke through the Crayola monopoly.